We have been thinking about various properties of electricity and electric circuits, and we're now going to see how, using some of these properties, electrical equipment can be developed and used to good effect. But first, a word or two of revision. You'll remember that dart notation for direction of current. Current toward you, you see the point of the dart. Current away from you, and you see the flights. We'll need this in a moment to explain this experiment. We have two bar magnets set either side of a small dish of salt water, which is a good conductor. Dipping into the water is a red wire swinging from another wire, which is connected to a battery. To complete the circuit, a blue wire leads from the water to the other battery terminal by way of a switch. When the switch is closed and current flows, look what happens. The red wire swings in the magnetic field. Now let's reverse the magnets to reverse the magnetic field. This time the wire moves the other way. We have just seen one of the most fundamental and useful effects in the whole study of electricity. We had a magnetic field with the wire going through it at right angles. When a current was passed through the wire, it moved to cut across the lines of force. This is called the motor effect and is the basis of all electric motors. We need to be able to predict which way the wire will move. And there is a right-hand rule which tells us. You hold your right hand like this, with the thumb and first two fingers pointing in different directions at right angles to each other. Then you hold your hand so that the first finger points in the direction of the field. F for first and F for field. You line up your second finger with the direction of the current. There's a C in second, and C is for current. Now the direction in which the thumb points gives you the direction of motion. There's an M in thumb, and M is for motion. Remember, this is the motor effect, and it is a right-hand rule. In the experiment, when the current was flowing up the wire and the field was away from us, the wire moved to the right. On the diagram, the field was from right to left, and the current was toward us. So, which way would the wire move? We'll try it with the right-hand rule. First finger field, second finger current, thumb motion. The wire moved up the screen. And now, using the motor effect, let's see if we can make a simple electric motor. We take a rectangular loop of wire and put it in a magnetic field. If we pass a current around the loop in this direction, the far side will move up and the nearest side down. If at the moment when the loop is vertical in the magnetic field, we could reverse the direction of the current, the force that had been pulling the top wire up would change to one pulling it down, and the loop would go on moving. This change of direction of the current can be brought about by means of a ring split into two halves and connected to the loop, and carbon blocks called brushes, carrying the current to and from the half rings. Now, in this position, the negative brush is in contact with the near side wire, and it is moving up. What when the loop rotates to this position and wants the upper wire to start moving down, the connections change over, and the current in the loop changes direction, keeping the rotation going. Here it is in practice, a DC motor comprising a single loop of wire revolving in a magnetic field. The loop of wire is called the armature, and the arrangement of split rings and brushes is called the commutator. Now let's take our simple motor and connect it to a current measuring instrument instead of to a voltage supply. If we make the armature spin in the field, a voltage is generated and a current flows. What was an electric motor has become a generator of electricity. So in a motor, current flowing in a magnetic field causes motion of the conductor across the field. In a generator, motion across the field causes current to flow in the conductor. And just as we had a right-hand rule for motors, we have a left-hand rule for generators. As before, the first finger points in the direction of the field. The thumb points in the direction of the motion. And the second finger will point in the direction of the current. Try it in this case, where the far side of the loop is moving upwards. First finger, field, thumb, motion, second finger, direction of current. This way. And that's the end of our look at motors and generators. In the next part, we will look at some miscellaneous electrical equipment.